Introduce Shawn Lucas with sorry, did you hit record? You got it. All right. Dr. Shawn Lucas with Kentucky State University, using labile carbon to identify low carbon soils and monitor carbon sequestration. So Shawn.
Thank you. Well, this is a career first today. There was a confusion this morning, I guess, and that was my fault. Those beds over there are mighty comfortable. And I was up doing a grant report last night, and then the next thing I did was tweak this presentation. I think it said 12:20. I went to bed and I laid there and heard my phone, but oh crap, that clock can't be right. So thank you to the inn for having some pretty nice beds. I'm not here to talk about that, though. I'm here to talk about carbon, soil health, and using labile carbon. And I should apologize and not make a joke, but I'm sorry for running a little late this morning. I've been working with labile carbon pretty much since I was a master's student at University of Maryland with Ray Weil, and using that as a test to assess soil health. And so I'm going to talk a little bit about my experience and just give a little bit of background on it. This is a nice cover crop we grew at Kentucky State last year. We're actually starting. I primarily most of my work is in the organic sector, organic ag sector, and so we're starting to do some work with organic no-till and trying to figure out what works with organic no-till in Kentucky as far as crimper rollers, cover crop density. How successful can we be in terms of weed suppression? So this is one of our plots that we were using as a pilot plot last year. It's a pretty nice stand of rye, I think. Didn't roll down too well until I got it into anthesis. I had to call Steve Groff to figure out what the heck I was doing wrong. He was kind enough to help me. Oops, that's the wrong keyboard. There we go. All right, so soil health has been around for a while. We've been hearing it for 20 years now. I think Dr. Dick was involved in some of the original conversations of defining soil quality when the Soil Science Society of America was trying to come up with a good definition like 2.5 decades ago. And it depends on what you're using it for. If you're thinking about soil quality, are you trying to build a house with a good foundation? You probably don't want shrinking and swelling clays in that soil. That's not soil quality for that particular use. For growing crops, we want healthy soils that cycle nutrients, provide for root penetration, provide for air flow and water holding. And so we need to consider the health of the soil or the quality of the soil in those terms when we're thinking about crop production. Coffee hasn't even kicked in yet. Lately, we've been going with soil health because scientists have realized the importance of biological activity and biological cycling. And then we get into the idea of how do we assess soil health? It's been kind of challenging. People have come up with, back in the 90s and early 2000s, people came up with pretty wide ranging soil quality indexes. And we still don't have like a one-shot, measurement that we can say, oh, that's soil health, that quantifies soil health. Because it really takes into account the big picture, and you got to look at the total functionality of the soil. If we can understand all that, though, we can probably do a reasonably good job at helping farmers make good management decisions in their operations. And that's really what we're all about. It's another cover crop. That's a picture I stole from NRCS, and I've always liked that picture. It's a good mixed cover crop. You got some rye, you got some hairy vetch, and some clover in there, but that's a nice dense cover crop. So when we're talking about soil health, at least in terms of what we can manage, you can't really change the texture of your soil. You can't really change your slope unless you get real ambitious. What can we change? What can we manage in terms of affecting soil health? Well, soil organic matter. We figured out, by now that we can manage soil organic matter. And this is important because, again, it's related to nutrient cycling, soil structure, which is helps determine soil airflow, soil water movement. And this is the biological activity, and particularly for me involved in organic ag, this is where it's all counting for me. I can't go put in, 120 pounds of ammonium nitrate and expect an immediate response in the systems I'm running. I have to be counting on this biological activity to break down the cover crop residues, the manure, whatever I'm using. So this is the food for the microorganisms, and of course, those microorganisms are responsible for that nutrient cycling and all the other processes that help determine that soil structure. This is a nice picture of a good healthy soil with an earthworm moving through it. This stuff responds to management. We know how to build soil organic matter, and we're always trying to figure out to do better. We know how we break it down. In this picture here with the moldboard plow, you're aerating the soil, you're turning that soil over, you're breaking those soil aggregates up, and you're allowing a lot of air to rush into those aggregates. You're freeing up soil organic matter that's been trapped in those aggregates, and the microorganisms can go crazy, and it's a buffet for them. And so they eat that soil organic matter up, and we lose a lot of that organic matter to carbon dioxide and released to the atmosphere when we're doing these kind of tillage operations over time, a lot over time. And just as a rule of thumb, I send my soil sample in, and I'm in Kentucky, so I send my samples to University of Kentucky Regulatory Services. And they'll give me a report on soil organic matter, but they're not really reporting soil organic matter. They're measuring carbon, and then they do a calculation based on the fact that soil organic matter is 58% carbon. So they do a calculation based on burning off the carbon. So as I said, we can affect soil organic matter in ways that are positive or negative, or we can just, find some kind of an equilibrium, so here's where we might be doing a whole lot of intensive tillage, not putting those organic inputs like cover crops, or again, in my world where I'm working with organic, we use a lot of composts and manures, that puts organic matter back in the soil. If we're not doing those things and we're doing a lot of tillage, this might be the trajectory we're on. On the other hand, if you're doing those good things where you're adding soil organic matter, getting good cover crop use, good crop rotations, you might be on the improvement side of things. And whenever you are doing these things, it doesn't keep declining or keep improving. At some point, you're going to reach some kind of a stabilization where it may ebb and flow based on operations, but your organic matter is going to stabilize to some degree. So again, back to soil health, we have to think about soil health in terms of all the functions that a soil carries out. And if we're thinking about it in terms of crops, it's all the things that it delivers to our crops. We can't just measure crop yield. Yeah, that's the most important thing that we want. It determines a farmer's living, but that's not the only parameter. A good, healthy soil is going to, soil is the first line of defense when you get a rainfall event. Does that soil allow that water to soak in, or does it run off and cause a lot of trouble? We had floods in eastern Kentucky 2 years ago because the rainfall fell in high amounts on areas that had been subjected to mountaintop removal mining. And they come back, they put the land back on the original contour, but that's a heavily compacted area. You don't have the forest there. And we had massive torrential rains, and the folks in the hollers got flooded out. That's a function of the soil not being able to absorb that water. So soil health, the big picture, looks at all these things. You have to evaluate how it performs all its functions. And again, that carbon component helps determine how that soil behaves. Carbon is tied to, and I think back to my days as a graduate student, both at Maryland and at Ohio State, sitting in Warren's class at one point, I thought, man, being a soil scientist is cool, because you can't just think about, you could be a biologist and you're straight biology. That's a pure science. you could be a physicist and build rocket ships. That's a pretty pure science. Chemistry, that's pretty pure. But to be a soil scientist, you got to figure out how the heck all these things work together. And organic matter is related to biology, physics, and chemistry. The biology of the soil is related to the amount of carbon in the soil, decomposition processes, residue decomposition, nutrient cycle. This is all biological. It's all related to soil organic carbon. Physical properties. Well, aggregate stability is a physical property that's affected by the biological properties. And again, this determines soil structure, bulk density, porosity, air movement, air flow, water holding capacity, and again, infiltration. And then the chemistry. The more organic matter you have, the better your cation exchange capacity is, which affects nutrient holding capacity. But it can also do things like serve as a filter. CEC absorbs metals, pesticides, herbicides, different organic compounds. And so it's kind of acting as a filter. Again, that soil health is that whole functional process. I like to use, when I'm thinking about organic matter, I like to just give a little bit. I think we're all probably familiar with it at this point, but I always like to give a little primer on it. And I like to go back to Dr. Fred Magdoff's primer, where there are 3 kinds of organic matter: the living, the dead, and the very dead. And so what's the living? The living is like the plant roots, the small organisms that live in the soil, arachnids, mites, nematodes, microorganisms like bacteria and fungi. And I love this picture. I've seen this picture. I use this picture in my classes at Kentucky State. This is a root. It's the tip of a root. My students often look at this and like, well, this looks like a root. No, that's a fungus working through the soil and wrapping itself around soil particles and helping develop good aggregation. And then I like to point out that these little wispy things on the tips of the roots are also fungi. Those are mycorrhizal fungi. And so a good healthy soil should have a nice smattering of bacteria in there. And generally speaking, the bacteria or the biological activity in a healthy soil is higher than in a less healthy soil. All right, so the dead. What are the dead things? Well, these are, seems pretty common sense, right? The dead, the stuff that recently died, decaying stalks, residues. This is food for microorganisms. This is the stuff that as it decomposes, it releases nutrients pretty rapidly. I really depend on this again in the organic systems I run. These are the Blevins plots down at University of Kentucky, the long-term no-till Blevins plots. I think one time when I was a graduate student here at Ohio State, I saw the same phenomena at the triplet Van Doren plots. I like to point this out. This is a long-term tilled plot, or this is a long-term tilled plot, I'm sorry. And this is a long-term no-till plot. And if you look real close, you can see that the no-till plot's actually higher in elevation. And I think just like the triplet Van Doren plots, this is not a slopey area. There probably hasn't been a whole lot of erosion here. The differential is probably due to the bulk density of the soil that's changed over 40 plus years of no-till versus till. So that's long-term impact of organic matter and management. Then you got the very dead, the stuff that has decomposed to the point where it's at its most basic levels of decomposition. You have really stabilized materials that, it'd be like trying to chew on a piece of rubber if you were a microorganism. It doesn't want to break down very easily, very little nutrient release, but it has a lot of this soil chemical properties. It's what provides a lot of the dark color to our soils. And this is the stuff that's nice and kind of fluffy and provides that air holding capacity and and air movement and water holding capacity, and really facilitates soil structure. And the meat and potatoes of this is, this is why we're here, why we care about this. At this point in our history as a people, we know that, all right, we may not like to talk about it, but we know we've got more carbon in the atmosphere than we want to have in the atmosphere, and it's causing things to change, and we're having to respond and adapt. If we can keep the carbon in the soil, it's going to do good things. It's going to provide nutrients to our crops. do all those good things I just talked about in terms of soil health and the functionality of the soil. So if we manage our systems well, the things that we're doing to help our soils are also helping our atmospheres and the carbon problem in the atmosphere. And you all have been around probably farming for a long time. A lot of you. Farmers know what soil health looks like. Farmers can look at a soil from the way it feels. You don't have to have fancy tests to do this if you've been active in farming for a long time and you're familiar with your fields and your operation. How does the soil feel? Does it crumble into aggregates when it's broken by, with your hand, or does it break into hard clods? How's it smell? I mean, there's a nice earthy smell that you get. I like to think if you're out in the forest and you clear that top layer of leaves away and pick up that real brown fluffy stuff, if your farm soil is approaching that, you're probably doing a pretty good job. Those are the smells that come out of some soils are indicators of certain types of microbial activity, and those are generally associated with good health. How's it look? We can probably all look at this picture and to tell which one is the healthy soil, right? If you all had to take a guess, which one is the healthier soil? Is it right or left? Yeah, I mean, it's got that nice color. You can look at it, and even in this grainy picture, you can see that it's got, a little more structure. You can see the roots penetrating. That's the same soil. One neighbor's field was managed with long-term tillage. The other neighbor's field was managed with long-term no-till. And the no-till one, of course, is on the right, but it's the same soil series. They had been farmed for a similar amount of time, but that's the difference between tillage and no-till. And Joel Groover was a colleague of mine when I was at University of Maryland as a graduate student, and he did some work to really show that, like, farmers' perception of soil quality is really correlated with all these characteristics of a soil that are related to soil organic matter. So if we're trying to measure soil health, we can't pick things like water content. It could rain tomorrow and that's going to change. pH, yeah, that's going to affect how well our crop is, the crop productivity, but the pH, we could change that pretty quickly. That's not really a good determinant. Mineral nitrogen, other things that we can influence by adding fertilizer, those are not good indicators of soil health because they change too quickly. And of course, soil depth, soil texture, the climate, we don't really have control over that. The parent material, up here were what, lacustrine sediments and glacial till. Where I am in Kentucky, it's limestone bedrock is the parent material. That's what all our soils are formed in. Can't change that. What we can change is this column in the middle through management. And that changes over a couple years. Microbial activity, soil structure through aggregation. And then we get into some of these carbon measurements. You send your soil test in, you get a measurement of soil organic matter. Like I said, they're really measuring total organic carbon by combustion. And then you can also measure what we call labile or active carbon. And I think Scott, I caught the end of his thing, and he was talking a little bit about labile carbon, but that is the carbon that's more easily accessible to microorganisms, more easily broken down, and that's just the part that really facilitates some of these nutrient cycling processes. If farmers want to test this stuff, right now there are limited options. Do they have anybody here in the state of Ohio that does biological testing? I know Soil Health Lab at Ohio State used to do some of this. Is that still active? So Ohio State is doing some soil health assessment where you're measuring some of these characteristics. I'm in Kentucky. There is no university lab offering these, although if I have my druthers, maybe my lab is going to start. But for farmers in Kentucky, if they're interested in this, they go to Waters Ag and they offer a bunch of different tests. The Solvita CO2 burst test, the Solvita SLAN test, which is a measure of sort of active nitrogen. They actually will offer this active carbon test based on potassium permanganate, which I'm going to talk a little bit more about and I'm pretty familiar with. And Dr. Islam helped develop that test. And aggregate stability and organic matter. So you can get all those, but these tests are expensive. And then you still have to figure out, well, how the heck do I interpret all these? So a quick and easy way to sort of get a sense of what your carbon looks like, even in the field, is with this permanganate oxidizable carbon. This is an old handheld kit when my hair wasn't gray, and this was back in the late 90s, early 2000s at University of Maryland. And we were out in the field measuring permanganate oxidizable carbon using this handheld spectrophotometer. This test is basically a measure of color change in a solution. The more organic matter there is in your soil, the more the color is going to change. And so we would take this field kit out and shake up our soil with the potassium permanganate. And if you could see this picture, it has this one had a little less organic matter in it, and it's a little bit darker color. This one had a little more, and the pink color is a little more bleached. That's basically all this test is. It's quick, it's easy, and with the field spectrophotometers, it can be used in an on-field setting to get some basic information. It's sensitive to management. You got crop rotations, fallow periods, tillage. All those things have been shown to be, this test has been shown to be sensitive to all those things. And again, it's a basic shake, let it settle. You measure the color difference. This was the old handheld spectrophotometer that we had 20 years ago at University of Maryland. So that's an old picture. 2 minutes of shake, 10 minutes of settling with calcium chloride. The calcium chloride allows those, reacts with the soil particles and allows them to settle out. You don't even need a centrifuge to do this. And again, you're measuring that color change. This test has been very closely associated with labile carbon. This is some work I did with Ray Weil at Maryland. And you've got a 0.94 correlation with total carbon. So this is what the soil testing lab will give you, and we're 94% correlated with the labile carbon test. This is something my graduate student did actually last semester. Manoj Paudel and an undergraduate student at Kentucky State worked with an incubation. And we had a control soil that had no amendments in it. We had a bunch of hemp sitting around because, unfortunately, I've had to work with hemp for the last 5 or 6 years in Kentucky. I'm one of our hemp specialists. I say unfortunately because a lot of farmers got burned by hemp. So we had a lot of residue sitting around, just like the farmers in Kentucky having big bags full of hemp sitting around. We had some too. So I said, well, let's do something good with it. So we amended the soil with it. We went out and collected some oak leaves in the forest. It was a pretty simple, straightforward study. We incubated it for 70 days. And this is after 70 days. So we also had biochar, right? And so we're all maybe familiar with biochar. It's basically charcoal in the soil, pyrolyzed carbon in the soil. But biochar we would expect to be very stabilized because it's almost, again, like charcoal, right? But after 70 days of incubation, where we amended these soils based on 0.01 grams of amendment carbon per gram of soil, permanganate's able to differentiate between the three treatments and the control. The biochar actually, I don't know if there was some kind of priming effect. It's not significantly different, but the biochar is actually slightly less carbon than the control. So what that tells me is this stuff isn't really attacking total carbon. It's attacking the mostly labile carbon. So we're picking up in other words, if we go back to the Fred Magdoff idea of the living, the dead, and the very dead, this stuff is measuring the dead stuff, not necessarily the very dead stuff. And again, that dead stuff is what our nutrient cycling and all our good soil health functions are coming from, where a lot of our good soil health functions are coming from. When I was at Maryland 20-some years ago, we worked with a cover cropping trial, and we wanted to see, we wanted to see the effects, and if we could detect the effects of cover crops in soils, and not just the effects, but the soil response to the cover crop treatment. And by response, we were measuring crop yield and we were measuring certain soil functions. And so generally speaking, what we found was we had a higher crop response where we had lower organic matter. In other words, and we were measuring the organic matter using this permanganate oxidizable carbon test. In other words, if you have a degraded soil and it's the same soil type as another soil next to it, but this one over here has been in good management for a long time, and this one over here has been in poor management. The one in poor management is going to show you more of a response, just like you can go through crop responses to fertilizers. Am I running out of time? And we saw a similar effect with mineralizable carbon. Mineralizable carbon was tied closely with permanganate. I'll skim over that one. That's some work. I'm just trying to show you, we had high levels of hemp residue on a soil a few years back at Kentucky State, and we were able to detect the plots that had the highest levels of hemp residue. Hemp is a crop where if you're growing it for fiber, you're taking all that crop off. That carbon is all getting removed with the crop. But this retting treatment, retting is where you leave the hemp on the soil surface to partially decompose for about a month, roughly speaking. And so when we did that process with higher levels of residues, higher levels of hemp on the soil, we were able to actually pick that up with the permanganate oxidizable carbon. I'm not saying that the retting is going to offset the amount of carbon lost in this particular situation, because again, you're eventually taking that whole carbon or that whole crop off and all the carbon that comes with it. But if you're adding this kind of a treatment in with other good management, you might be able to offset. These are some goats that we have in an integrated crop livestock system at Kentucky State. It's a 5-year rotation, 2 years of organic corn and soybean, followed by 3 years of goats on pasture. Where we figure it, we're damaging the soil during the cropping phase. Because we're organic, we have to do tillage for weed control, so we're doing a lot of tillage. We come back and we run the goats on pasture for 3 years, and we're hoping that through the non-disturbance of the soil with the pasture, and then the goats doing their thing. What's their thing? Well, they chew and they poop, right? So there's a corn crop, there's a pasture that had goats on it, just recently grazed, and this is a check plot that has pasture, but the goats don't graze it. Here's what the goats leave behind, right? They do their business. And again, this is undisturbed pasture with animals on it. And so over time, what we saw, this is a check plot where we just till and plant corn or soybean every year. This is a check plot where we're always in pasture. In the corn phase, the labile carbon is similar to the check plot where we're tilling all the time. A little bit different in soybean, but again, it's low. As we go through these pasture phases, pasture year 1, pasture year 2, pasture year 3, we're starting to approach, by year 3, the undisturbed pasture levels of soil, of potassium permanganate oxidizable carbon. In other words, we're offsetting some of that damage that we're doing. I'll skip that one. We basically saw the same trend in aggregates in that system. So not only does permanganate pick that up, but we are seeing it in these soil function parameters. Basically, this is good as a predictive tool. It doesn't give you, you can't use permanganate and say this is definitely a good reading or a bad reading. You have to start with a baseline and see if you're adding, but you might be able to use it to identify soils in regions where good characteristics of soils are known. You might be able to identify soils where, hey, if we use good management practices, we can improve the productivity of these soils, or we could sequester carbon and offset climate change. We need more people out here talking about this, outreach and extension. Dr. Islam and Jim Horman a couple years ago put a financial number to what soil organic matter was worth, $680 an acre in organic nutrients. In other words, you would save $680 an acre. If you have a good, healthy soil, you could potentially save $680 an acre in fertilizer inputs. Am I on that right, Rafiq? So, but this is Ohio. Does that is that number the same in Alabama or California? We need more people looking at that and figuring that stuff out. Dr. or Mike Estad is going to be here later talking about valuation of carbon, but we need a lot more people thinking about that. How farmers could take advantage of all the incentivization, climate smart projects that are out there now and get paid for the good management that they're doing. And we need to continue working on, understanding the global carbon markets and assessment. That's all I got. I'm sorry I overslept this morning. Those beds are good though over there at the end.